Good morning. We are going to, I know I said we would do chapter 12, but I forgot that when I start with chapter 12, I actually start with section 10.6, and then I translate it. That way the whole chapter is specifically about circles. So for this, what I've decided to do is I've gone through the entire notes and I've typed in blue the definitions. Okay, and I'm going to kind of breeze through these because the notes are long. I want to get it done in one shot. You can screenshot these, copy them down, whatever you need to do to get these. I'll touch on them, but I'm not going to write them all out. So like I said, we're going to talk about a circle. The circle is basically the set of all points that are equidistant from the same point, which is the center. The center is how we name a circle, so this is important to know. If you have a circle and the middle point is labeled P, then that would be just called circle P. Okay. The diameter is the segment that contains the center of the circle, and both endpoints are on the circle. So the diameter passes through the center, and it starts and stops on the circle. The radius is half the diameter, as I'm sure you've been told a few times in your math career. It travels from the center, and it stops on one point of the circle. You can draw infinitely many radii and diameters in a circle, and all radii of the same circle are all congruent, and so that's one way to know that a circle is congruent. As the next statement says, congruent circles have congruent radii. And then lastly, the central angle, and this is kind of a big one. This is really the new thing to you, and it's something that kids miss script a lot. A central angle means that if you have two radii drawn in the circle, okay, that vertex, that angle measurement is going to be the same as the arc measurement. And the definition is, of course, that the vertex is on the center of the circle. I know it's a bad drawing, but you get the idea. Okay? Little diagram down here to show you the labeling. Angle APC would be a central angle. P is obviously the center of the circle. AB is a diameter. It passes through the center and has endpoints A and B both lie in the circle. And PC is the radius. It starts at the center and ends on the edge of the circle there. So there's a good picture for you, better than the little drawings I had. Now, this is going to be new stuff for you. And here are the definitions again for you, so you can pause this, copy them down, then listen to my explanation. A semicircle, the etymology of the word is exactly true. Semi means half. It's half the circle. Okay? You name this with 3 points. I'm going to talk about that here in a minute. A minor arc is smaller than a semicircle, and it is only named by 2 points. So, for example, it would be called arc AB, and you put a little arc mark above it to indicate it's an arc, not a line segment. And then a major arc is larger than a semicircle, and it is named with 3 points. So, for example, if you wanted to say arc ABC, you would have 3 points and still have that arc mark above it. Okay, and I'm going to explain to you why you need 3 points to name these. So, here's another example of this stuff. Okay, major arc STR. So, let's start with the minor arc first. Let's start here with the minor arc. A minor arc has to be less than 180. Think of like if you're a minor, you're under 18. If you're a minor arc, you're less than 180 degrees. So here is your minor arc. It is certainly less than a semicircle. Okay. So that would just simply be arc RS. If we want to name a major arc, the reason why you have to use 3 terms is so you know what direction you're traveling. Okay, so let's actually make a point here. We could not say that RST was a major arc. It looks to be a semicircle. We don't know that for sure. Okay, but it's certainly not bigger than 180 degrees. So that would be an incorrect way to name a major arc. Now, if I change the lettering and I say arc RTS, well, that's clearly bigger than 180. It has my 3 points. So arc RTS or STR, depending on what direction you travel, is a major arc. Okay? Now, these would be the examples we would do together in class, so I'm not going to name all of them again for time's sake. I will say order does not matter in terms of, especially for minor arcs. So if you said arc AD or arc DA, they are the same arc. Okay, that would be this arc right here. So they're asking you to name some minor arcs. So obviously AD is 1. AC would be 1. CE would be 1. And then DE also would be a minor arc. Semicircles. Okay, so now it has to be half the circle. And DC and AE are both diameters of the circle, so that tells me that I can name a semicircle. Now, if I want to name a semicircle, let's say that you spotted this semicircle and you wanted to name it. Okay, the order does matter in the sense that you can't say DCA because that doesn't follow the path. Okay, you would need to say DAC. Or if you wanted to name this semicircle down here, that would be DEC. Starting at D to E to C would be another one. You could use EDA. You could say, I'm trying to find some unique ones here. You could say CED. You could say ACE. All of those would be acceptable answers for a semicircle. Now, on to the major arc. So this has to be bigger than a semicircle. So let's just start at point D, for example. Now, you're allowed to travel along a circle and skip letters, right? So I could say arc DCE if I chose. I could also say DAE. DAE if I wanted to. Now, I don't have to start at point D either. I could start at any point I choose. Let's say I start at C. I could say CEA. Or you could say CEA. If I said CED, I would stop short of being a major arc. I'd be a semicircle. Okay, but I could say CEA. I could say that as well if I wanted to. And don't forget your arc mark over there. Okay. Now this would be the point where I would say, in this next example, you would do this on your own and then take a shot at it. I'm going to not do these examples. What I'm going to do instead is show you some of my sample answers. Again, if you have QP instead of PQ, that would be correct. You could certainly have different answers than what I've listed. I just listed a handful of them to give you an idea to check. If you have any questions about this, I know I'm going through this kind of quickly, but I want to get through this whole thing in one video. Shoot me an email and say, Mr. Senator, on the example where I had to name the major and minor arcs, would, SR be an acceptable answer? And I would say, yes, of course it is, or no, it would not, and I'll explain to you why it would not be. So go ahead and take a minute, pause this if you need to check what you've tried on your own. We're going to move on here. This is the nitty-gritty, really what the content's after here. Arc measurement. So you're going to talk about two things today. We're going to talk about arc measurement, and we're going to talk about arc length. They are vastly different, even though the names are very, very similar. Arc measurement is the exact same value as the central angle. So think back to that definition I gave you earlier. A central angle is an angle in a circle in which the center, or the vertex rather, of the angle is in the center of the circle. So in this case, okay, angle S is 50 degrees. The arc measurement of RT is the exact same thing as that central angle. It is 50 degrees. Okay? Now the next question asks to find the major arc, and I know it's a major arc because they listed three terms. They wanted me to find the measurement of arc TQR. Well, fundamentally, you got to know that there are 360 degrees in every single circle. So if you don't know that, make a note to know that there are 360 degrees in all circles. So just like the triangle angle sum theorem, it's the same logic that's applied here. There's 360 degrees from this point all the way around to this point. If I know that from here to here is 50, okay, well, to go from here all the way around to there would be 360. subtract 50. So the measure of arc RQT is 360 minus 50, which is 310. Okay. Adjacent arcs, they're just arcs that have something exactly 1 point in common. Remember, adjacent is that fancy word for next to. Okay, so for example here, if you have two arcs, A, B, C, arc CB and arc AB are adjacent. They share that point right there. Okay, I know it's a quick, sloppy drawing, but you get the idea. Arc addition postulate is no different than the segment addition postulate you learned back in September. If you have, let's say for example that, to make the math really, really easy, let's say that this arc measurement was 50 degrees and AB was 50 degrees, and let's say the arc BC was 100 degrees, well then the arc measurement of AC, which is still a minor arc, would be 150 degrees because I would add these two values together. Okay, that's all it's saying. You have two arcs that are next to each other or parts of each other. You can add them up to get the total. Okay, so here's our first example. This is really the geometry part of it. The math isn't hard. It's just simple, arithmetic at the end of the day. So remember, central angle and arc measurement are interchangeable. They're the same value. So if I take a look at, and again, it's important that you once we find information out, it's very important that you label this together. We got to find these four values. These four different arc measurements. Okay, let's take a look at the circle real fast. If the central angle COB is 32 degrees, well then I know that that arc measurement is also 32 degrees. Okay, now that's not as advantageous to know that this angle here is 58 because they're asking all about arc measurements. Okay, but this would also be 58 if you ever needed to know that or to help you out in any way. So, arc BC is 32, arc CD is 58, and we don't really know much else except we are given that CA is a diameter of the circle, and I know that because C and A are endpoints on the circle and they pass through circle or point O, which is the center of our circle. Okay, so without really looking at what I need to find, okay, I know that from C to D to A, I know that is 180 degrees because that is a semicircle. Same from C to B to A. Those are both 180 degrees. Well, to find arc DA, D is in dog A, I can simply take 180 and subtract from it 58. And when I do that, I get 122 degrees. So arc DA is 122. So down here, well, they don't ask for that, but that's okay. Never hurts to know more than you need to. All right. Well, they do ask for BA or AB, and I can do the exact same logic here. Okay, from C to B to A is 180. Subtract from it what I know of 32. And when I do that, that gives me 148 degrees for arc BA. Or AB, which they asked for, which we said was 148. Now, they're asking for BC. Well, we already figured that out. It was really given us as 32 degrees. They are also asking for BD. Okay, well, BD, no problem. To go from B to C is 32, and to go from C to D is 58. Well, that's just the direct application of the arc addition postulate. You take your 32, you add to it your 58, and this is actually 90 degrees. And we've already answered the last one. They're asking how much is the arc A, B, C. Well, we already identified that was a semicircle. Therefore, it is 180 degrees. Okay? So if there's any questions on that, shoot me an email. And again, pause it, take a shot at your next example here, answer these next couple questions. I'll go through these a little bit, not as extensive, but I'll at least explain how I got each answer there. Okay, so you should pause it, take a shot at it, and then check your answers here with me. All right, so right out of the gate, they want to know the length of PR, or I'm sorry, not the length, they want to know the measurement of arc PR. Well, again, the central angle is 77, so measure of arc PR is 77 degrees. That's just the central angle and the arc measurement are the exact same thing, okay? They want to find RS now also. Well, before I can know RS, it's important to see that PRS is a semicircle, okay? Now, they never ask for that angle, but it's 180 degrees. Well, to find RS, take your 180, subtract from it the part that you know of 77 degrees. Okay, and when you do that, you get 103 degrees for the measure of arc RS. And again, I like to write on the picture also so I see what I know. Now, they want to know the measurement of arc P. Let's erase some of the stuff here. PRQ. Okay, well, you could add 77, 103, and 28 all up to get your answer. You can actually work a little bit faster. You know PRS is 180. I'll just add 28 to 180, and when you do that, you get 208. And again, I did my 180 degrees plus the 28 degrees to get my full arc of PRQ. Okay? And then the very last one, they are asking for arc PQR. Well, you could add, this is a semicircle, PQS is a semicircle, so you could add 180 plus 103 to get your answer. Or the whole thing's 360. So if the whole thing's 360, this is the only part of the circle you do not want, which was 77 degrees. So what I actually did is I took 360 and subtracted out 77 from it and got a total of 283 for that arc. Okay, again, any questions, email me. Something that you don't understand how I got the answer, shoot me an email, and I'll be happy to address that. All right. Last definition or so, and then a couple theorems, and then 2 examples, and then we're done. So the circumference you learned probably in 5th or 6th grade is the distance around the circle. Okay, that equation is 2 pi r, or pi times diameter. They're the same thing, it just changes on what you know. Okay, so that's circumference. Is 2 pi r, or pi times diameter. And r, of course, is the radius of the circle. The arc length. So remember I said we had arc measurement. Arc measurement is degrees. It's the same measurement of the central angle. Arc length is different. You guys aren't going to like this because it requires you to use a fraction. Okay, but arc length is a fraction of the circumference. It's a part of the length around the circle. Okay? So, in this case, you should recognize this part of the formula. Okay, that part of the formula is your circumference formula. And you are going to take, or multiply it rather, by a fraction of the circle that you want. So, in this picture, let's make the math easy here. Let's pretend that AB is 60 degrees. Let's say that that arc measurement is 60 degrees. Okay? To find the arc length, and let's just say that the radius is, I don't know, 36. Make it really easy. Let's say the radius is 36. Okay? Or let's not do that. Let's make it 18. Make the radius 18. So we would have to use this formula. And this formula says to take the measurement of arc AB. Well, the measurement of arc AB is 60 degrees, and we're going to put that over 360. Okay? It's the part that I want over the entire circle. I'm going to multiply that by 2 times the radius. Well, the radius is 18. Multiply that by 2 is 36. Okay? Now, I think for this, what I'm going to do is I'm just going to let you use your calculator and type this in and give me a decimal as an answer. So you would just go in your calculator and you'd put this in parentheses. So you would say 60 divided by 360. Type in your calculator. It comes out to be 1/6. Not that you need to know that, but times 36, which gives you 6 pi as an answer. So here's what I'm going to do. I'm going to require you to do all of this in your calculator. You don't have to do it by hand. I would if we were in person, but I'm not going to make you do that now. So this would be required to do by hand, and you would just have to leave the pi on the end. I don't want a decimal answer. Okay, I want pi to be part of your answer. We'll do 2 examples. I'll make it a little more clear. On the notes, I'm not sure if you can see it or not, if your copy is black and white or in color, but they want you to find the arc of the part that is in red. So I will highlight that for you. I'll squiggle on it what the part you want. So in this example, we need to find the arc length of xy. Okay, well, the central angle is 90 degrees. That tells me that the arc measurement is also 90 degrees. So I want to take 90 degrees out of the 360 degrees, and I want to multiply that by the circumference of the circle. The circle circumference is, in this case, going to be pi times diameter because I'm given the full diameter. So I'm going to take 90 over 360, multiply that by 16 pi. I'm using pi times diameter because I was given the diameter. Okay? This works out to be 1/4 or 0.25. So this calculation I would let you do in your calculator. And it will end up being 4. We'll give you your answer, and then you just need to remember to put pi on the end of it. So 4 pi inches. So the calculator will give you 4. You just need to remember to stick pi as part of your answer because I do not want you to multiply 4 times pi. I want the exact answer of 4 pi. That's very important. You can at least do that much, especially for those of you that want to take pre-calc in 2 years. Okay, so that's your answer here. Again, you should pause the video, take a shot at your next example here on your own. I will show you before I go on that XPY is the part in red that you want to find. So pause it, calculate the arc length of XPY, and then unpause it and check your answer. So we want the arc length out of 360. I want 240 degrees of those 360. Okay, I'm going to multiply that by 2 pi r because I'm only given the radius here. That's the difference. I'm only given the radius, not the diameter. So take 15 times 2, that gives me 30 pi. That is the circumference of the full circle. I only want 240 out of 360 of 30 pi. So multiply your 240 over 360 by 30. You can do that in your calculator. It should give you 20. Okay. Yeah, it should give you 20. And then just reattach your pi centimeters there on the end. Okay? I know this was a lot. I know it was fast. If you have any questions, email me. Obviously, there's a homework assignment. So shoot me emails, get that to me, and I'll post videos and then we'll keep on chugging along here. All right, hope you guys are all doing well. I'll talk to you soon.